Okay, so this is a tedious calculation. It's not that bad though. So notice what we're going to do is we're computing curl. So we're going to take what we have here. That is our P. That is our Q, and that is our R. Right, and we're just going to, as instructed by this formula here, we're going to compute the 6 different partial derivatives and combine as instructed. Okay, so I'm going to do the first couple of these, and I'll let y'all do the rest of them, and it's going to be highly analogous. Okay, so we're going to start off with the partial of R with respect to Y. So R is that one. So we're going to take that thing, and we're going to take the partial with respect to Y. Okay, so this thing, partial with respect to Y. Okay. All right, now, good news. Even though there is a Z in the numerator, we're taking a partial with respect to Y. That means we're treating Z as if it's a constant, right? So I can rewrite this as, well, I'm taking the partial with respect to Y of, I'm just going to rewrite as negative Z x squared plus y squared plus z squared to the negative 3/2. And this is a kind of a power rule, chain rule calculation, pretty straightforward. And let's see, we get the negative z just comes along for the ride because it's a constant. Now I have times negative 3/2 x squared plus y squared plus z squared to the negative 3/2 minus 1, which is negative 5/2. But don't forget the chain rule. Now I've got to multiply by the derivative of the inside with respect to y, and that gives me 2y. Isn't that cool? Okay, so it's not that bad, right? So times 6. You just have to do this 5 more times. Okay, so the next one that I have to compute, let's see, going back up to the formula, I need to compute the partial of q with respect to z. Okay, well, q is that one. It's the second one. Okay, so that thing, we're going to take the partial with respect to z. All right. Okay, partial with respect to z. Now, again, good news. We're taking a partial with respect to z. That means that, again, our numerator is a constant as far as our z partial is concerned. So I'm going to rewrite with that in mind. And we're going to get a pretty similar looking answer, as it turns out. So we get the negative y, again, still a constant, so it just sticks along, stays there for the, along for the ride. Then we're going to have negative 3/2, all this business, to the negative 5/2. Make that parenthesis better. There we go. And then again, chain rule. Now we're taking the derivative with respect to z of the inside, and so we get 2z. Okay, so the first component, we've done 2 of the 6 partial derivatives. The first component of the curl that we need to compute is that minus that. So it's this thing minus that thing. And if you notice, I mean, they have a lot in common, and in fact, they're identical. So we're subtracting 2 things that are exactly equal to each other. So that first coordinate 0. Yeah. And it's going to be a morally equivalent. So this, this ended up being 0. Morally equivalent calculation that I'll leave as an exercise for y'all to do here and here. And they'll also be 0, as it turns out. And then just a little bit of foreshadowing. The fact that, for this vector field, the fact that the curl is equal to 0, this actually has a physical significance. When we get later into Chapter 6, and we're talking about the physical interpretations of divergence and curl, there is a consequence in physics to the fact that this answer is 0. Yeah, so more on that in Chapter 6. Everybody good?
Can you explain why it's equal to 0? I mean, because we don't know the value of y or z, right?
Yeah, well, that's right. But so the point is, this is equal to 0. The difference between these two things is 0 for no matter what y and z are, because they have the exact same factors. I mean, this has a factor of z, that has a factor of z. This has a factor of y, that has a factor of y. They have the same number of minus signs. They have the same number of 3's and 2's, and they're identical expressions when you multiply them out. So yeah, so for all values of x and y, you always get 0. Yeah. Unless x, y, and z are all 0, in which case it's undefined. But yeah. Right. Cool. Okay. Great. Let me stop the recording here.
Thank you.